Hello everyone. We are a group of three students, Khushi, Kirti and Lakshita from ABS IT Ghaziabad, presenting our final year project titled Real-Time Driver Drowsiness Detection using Computer Vision. Our project is guided by Ms. Swati Joshi from the Department of Computer Science and Engineering and is registered under PID 34. Let's understand what we are going to read in this PPT. Abstract, introduction, objective, literature survey, problem statement, proposed solution, conclusion, and references. So, our project is based on driver drowsiness detection system that helps to find out if a driver is feeling sleepy while driving. We have used a webcam to keep an eye on the driver face in real time. The system checks for signs like eye blinking, yawning, and which usually happen when someone feels tired. For this, we used a method called EAR, eye aspect ratio, which tells us if the driver eyes are staying closed for longer than usual. If such signs are detected, the system quickly gives an alert in the form of sound, light, vibration, so that the driver wakes up and becomes alert. This method is non intrusive, meaning the driver doesn't need to wear any special device. It works on real life situation and can be used in personal car as well as commercial vehicles. In future, the system can be improved and added to self-driving vehicles or used with other safety systems to make roads safer for everyone. Now, driver drowsiness is one of the biggest reasons for road accidents across the world. Every year, thousands of people lose their lives just because they fall asleep or lose focus while driving. When a driver is tired or sleepy, their reaction time slows down, their attention decreases, and they make poor decisions, which can be very dangerous on the road. Earlier, it was hard to detect drowsiness while driving, but now, with the help of technology, we can create systems that can monitor the driver face and find signs of sleepiness in real time. These systems use computer vision where a camera keeps track of facial movements like blinking, yawning, or head nodding to understand how alert the driver is. As soon as signs of drowsiness are detected, the system can give a quick alert through the sound, light, or even vibration to wake the driver up and grab their attention. The main goal of our project is give drivers early warning. Now, key points of our projects are drowsiness driving is major contributor to serious accidents, AIMN enables real-time fatigue detection, and this system identifies gestures. Our goal is to improve road safety.
Our project has a single overarching goal to make roads safer by detecting driver fatigue before it causes an accident. And the key points are: point number one, select the most effective facial analysis techniques. We survey state of the art face landmark and eye tracking methods, then combine them with proven metrics such as eye aspect ratio and mouth aspect ratio to quantify drowsiness. Point number two, boost accuracy with deep learning convolutional neural networks are trained on diverse driving condition data sets so that the system performs reliably even in low light with occasional such as glasses and across different driver ethnicities and behaviors. Point number three, solve real-time deployment challenges. The model is optimized to run on device at video frame rates, overcoming issues such as poor lighting, motion blur, and camera vibrations that occur in actual vehicles. Point number four, address ethical and privacy concerns. We keep all processing local to the vehicle, do not store biometric images, and encrypt any aggregated analytics that leave the device, ensuring GDPR complement privacy protection. Together, these four objectives ensure our solution is not only accurate in the lab but also practical and responsible in the real world. Now, coming to the literature survey, research into drowsiness detection falls into three broad categories: vehicle behavior monitoring, physiological signal monitoring, and vision based analysis. Vision based methods now dominate because they are non intrusive and cheaper than EEG headsets or steering wheel sensors. For example, Biswal had created an IoT camera system that analyzes 8 frames per second and issues alerts in real time. Jabbar ported a CNN model to Android, providing mobile feasibility, yet both struggling with lightning challenges and driver diversity. Vehicle behavior methods: watch lane position or steering wheel angle. They work best on highways but perform poorly in city traffic where lane markings are absent. Physiological signals approaches like EEG detect brain wave patterns with high precision but require drivers to wear uncomfortable sensors, making adoption unlikely. A comparative study of 7 landmark papers Raghuvaran 2021, IEEE Care 2019, among others, shows no single system yet meets the combined requirements of high accuracy, low intrusiveness, and robustness to environment. False positive remains common, especially under poor illumination or with head movements. Our contribution is to fuse EAR, MAR, geometric cues with lightweight CNN trained on an augmented dataset covering nighttime glare, sunglasses, and ethnic variety to cut false alarms and keep inference under 40 ms per frame. In short, we close the gap between lab prototypes and deployable in car safety.
In our proposed work, we aim to develop a machine learning based driver drowsiness detection system. The main goal is to prevent road accidents caused by driver fatigue. We use a real time webcam to monitor the driver face, especially focusing on eye blinking pattern and yawning behavior. Our solution is divided into three major parts. First, input part, second, pre-processing and processing part, third, output part. Input part, we capture live video frames using the camera. These frames are analyzed to detect the driver face and facial landmarks, including eyes and mouth. Pre-processing and processing part, first we examine the eye aspect ratio EAR and mouth aspect ratio MAR using landmark detection. EAR helps in identifying eye closure and blinking pattern. MAR helps in detecting yawning. These ratios are calculated using DLib and OpenCV. If the EAR is below a certain threshold, for a few consecutive frames, or if MAR indicates yawning, it is considered a sign of drowsiness. Output part. When drowsiness is detected, the system triggers a beep sound. This helps in waking the driver and preventing accidents. Let's now explore the complete code structure of our driver drowsiness detection system. It's contain assets, which is images folder, which contain our images which show the drowsiness is detected like this, second image like this, it is eye aspect ratio, and third image is like this. Second, it is the model folder. This folder contain this pre-trained facial landmark detection model. Most commonly we use shape predictor 68 face landmarks.dat. This model is used to detect 68 key points on the face such as the eye, eyebrows, nose and mouth. It is crucial part of the system that allow us to calculate eye aspect ratio and mouth aspect ratio. Now we will go for our main file, that is driver drowsiness detection.py. This is central file of the project. When you run this file, it activates the webcam to start capturing live video, detects the face and landmarks in each frame, continuously check for signs of drowsiness like eye closure based on EAR, that is eye aspect ratio, yawning based on mouth aspect ratio, MAR. If drowsiness is detected, it triggers alerts, that is alarm. In short, this file connects all the parts of the project together and run complete application. Now fourth one is alarm MP3. These are the audio files that play when the drowsiness is detected. This system uses pay game or play sound to play a loud beep sound or a voice alert saying wake up. This alert helps wake the driver immediately and avoid accidents. Now let me show you how our project is running. When we will run this file, it will process, yeah, and it will come to this page. When we will click on a start detection, there are three options: start detection, stop detection and exit. First we will go for start detection. When we will click on it, then it will open the webcam. See, now our face is here, and when we will close our eyes, it will raise alert. Now we will stop the detection.
Now, I would like to conclude a project that using AI and machine learning in driver drowsiness detection is a big step forward for road safety. This system watches the driver's face in real time without bothering them and can spot early signs of tiredness. It helps prevent accidents by alerting the driver quickly. The system using things like eye and mouth movement analysis, smart computer learning, and automatic warnings to work accurately and fast. It can also adjust to different situations and might connect with smart devices and self-driving cars in the future. As an AI improves, this system will become very important for safer and better driving.
References: Anil Kumar Biswal, IoT-based smart alert system for drowsy driver detection, wireless communication and mobile computing 2021. Second, R. Jabbar, driver drowsiness detection model using CNN for Android. Proc IEEE Int Conference on Informatics, IoT and Enabling Technologies 2020. Third, M.Y. Hussain and F.P. George, IoT-based real-time drowsy detection system on Intelligent Informatics and Biomedical Sciences 2022. Fourth, Y.S. Kumar, IoT-based driver drowsiness detection and alert system, International Journal of Research and Analytical Review 2021. Fifth, Raghuvaran V. An IoT-based reliable driver drowsiness detection system, International Journal of Research and Analytical Review 2021. Sixth, K.S. Tiwari, IoT-based driver drowsiness detection and health monitoring, International Journal of Research and Analytic Review 2021. 7. ARCA AB, IoT-based driver drowsiness detection and collision avoidance using Raspberry, International Journal of Engineering Sciences and Research Technology 2020. 8. SV Katkar, Modeling and Simulation of WO3 for Supercapitals Research Studies in Mathematics and Computer Science, 2019. So, these are the references that we have taken in our project. Thank you.